10 years of AES67. We are going to celebrate today. There will be a reception later, and that's quite something. And we want to look at the motivation and the challenges and opportunities that actually came to us as a manufacturer when we decided to join AES67 in the journey. So we will look at the reason why we wanted to have AES67 in place, why we supported this, and then what the evolution was for us as a manufacturer, implementing this, improving everything, and then to see what we got from it. And we will take a look at what might come up next as a natural evolution of the current status. So let's start with the why.
Yeah, why did we need AES67, and what was interesting for us into going for AES67? So basically, Clodo and I, for the last 10 years, we've been working for a small company, or a small for Clodo, 3 small companies for me. And those small companies are really an incentive in going to AES67 for interoperability, because of the better coverage of all the use cases. Take, for instance, DIRECTOUT, mainly on the edges of the workflow, of the audio workflow. So having an interoperable standard would help this integration. And of course, if it's easily integrable, you can have a bigger market. You can solve more issues, you can solve more projects. And the open standard of it, which draws also both Digigram, merging technologies, and DIRECTOUT, amongst others, also to the Ravenna ecosystem, is the openness. And the openness which is really asked for in tenders for some broadcast providers, especially nationwide, who have very long renew cycle and need the technology to be available, even though the first manufacturer is not able to provide that.
Yeah, and it's also the requirement to integrate deeply into existing systems, and the possibility to actually tailor the solution to your needs, which is required and which is not possible with like black box systems that were available at that time. So looking at the possible business opportunities at that time, it was something that from the DirectOut, who was using a lot of MADI for multi-channel audio transmission, of course having an IP standard that does the same. We were looking at it as a possible replacement or successor of the MADI system. We were never scared that MADI would drop like this and not exist anymore, and we were right in that. It's still there and it's still valid. But of course IP has its place as well, and it does a similar thing, so it makes sense to have both of it from our point of view. Then the transport of high resolution audio formats, this was something particularly for you guys, right?
Yeah, for emerging technologies at that time, this was really important. Most of the high-level customers that use 8FS, so 384 kilohertz, to capture the signals were limited at 8 channels on a MADI link. So the availability of the gigabit Ethernet, allowing transport of 64 channels easily at 8FS, was really a game changer. And this is why Merging was one of the first companies to provide a solution, an end-to-end solution, so software driver and audio interface, because exactly there was a real use case and business case for that. And yeah, we can also talk about ASIP and Digigram, for who I was working at that time. And Digigram was doing contribution distribution with their ASIP stack. And the idea was just, okay, let's use this ASIP stack, which is not so far from the AES67, and add the missing pieces and expand our market on the ASIP.
Yeah, and another thing was the idea of reusing existing infrastructure. So Ethernet cables and fibers were available in a lot of buildings, and if there was the time to renew the facility with newer technology, going on IP would make it much easier to deploy audio signals in the whole building and well, make use of something that is already available with a more modern approach and more modern protocol. So this was also an idea why AES67 might be a good idea to use it. And then, of course, each computer has an Ethernet interface. So immediately you think of if we are on IP, if we have a network protocol, it would be nice to have a virtual sound cards to be able to record directly on your computers and have an exchange with that. This is also something which was in our minds when we were considering to join audio over IP and AES67. So what were the challenges when we started to look into this? Being a audio company, that's not just us. There are many in the market that they knew about doing rod clock, AES, MADI, analog I/O. So this is all audio baseband stuff. And looking at IP and Ethernet, this is a totally different game. So there's really an entirely new technology that needed to be learned. And well, thinking about IP and MAC addresses, TAI, PTP, yeah, I mean this was a challenging time just to grasp what we need to know about to get a grip on this technology, right?
Yeah, and including creating a new part of the industry. So the fact that audio meets network is really the best of both, or the worst of both. You can say that as you wish. But from the manufacturer perspective, the audio manufacturer, there was a lot of things to learn. So especially for DirectOut, emerging technologies who didn't have any IT tool at hand at the moment. Of course, in the audience here, we have people that were doing network way earlier than us. But we all have these stories of the first Plugfest where the stream had a MAC address of 000. Why? Because it was allowed. So actually it was not allowed, but it was possible. So as long as it is possible and nobody tells you it's not allowed, then you do it. Learning that Temps Atomique International TAI is not the same as UTC, and that there is some seconds between them was one of the fun things during the first Plugfest. And we all have this kind of things. So yeah, the Plugfest, they were key in growing knowledge within this community of AES, of companies spending time into a new technology and learning this new technology and building this new technology. Because of course the Plugfest was not only an occasion for us to learn, but also to better the standard and to ease the learning for other manufacturers to come. So this is the one in 2015. I think, yeah, it was at NPR, and yeah, that was fun.
Yeah, I mean these Plugfests were really important and helpful to figure out what was going wrong and to learn and get a grip on the technology itself. So, and once we did that and we started to have products that we wanted to deploy to the market, the whole issue was shifted towards the customer because they got overwhelmed by the same thing. So they were used to patch AES or MADI or XLRs between two devices, and now we said, yeah, you have to set up PTP and you have to know about RTP and you can read it up in the RFC, and then you have your IEEE and IGMP and QoS. And we're like, what? So we had to start and to understand that this is nothing that just works out of the box. So it's really something where we also have to educate the customers and the users and the integrators, because not only the end customers and the engineers actually working with the stuff, but also the integrators were probably not aware of how deep their knowledge needs to be able to specify and configure an Ethernet and IT system and switches and what they need to know to make it work. And also, we learned quite quickly that there's a big gap. I mean, Ethernet is not a new technology. It was not new when we started AES67. But the IT guys that knew very well how to set up a network and how to handle that, they did have no clue about audio. And the audio guys had no clue about the IT. So both sides needed to learn about the terms and the requirements of the other side. So if the audio guy went to the IT department and said, I have clicks in my audio, and they said, well, our switch only drops like 400, 500 packets. Where's the problem? And he was like, I need 0 packets. What? Why? You can retransmit it. No, I don't have the time to retransmit it. It needs to be there right now, and it must never drop. So this needed to be adapted and needed to be, well, trained.
Yeah, and so there's this joke that I tell every chance I have. You have a sound engineer and an IT technician talking, and the sound engineer says, "Oh, I'm missing a packet," and the IT technician says, "No, it's just delayed. Continue waiting." And this is the core of this business of doing audio over IP. It's both audio and IP, and again, for this training, they were really needed. We have a ton of stories about customers using weird IP addresses because they just didn't know about the public the public and private IP address. We have funny network technology or topologies because they were plugging things everything, etc. So yeah, eventually we realized that it was not only about learning, but also the tools that were missing. Some of them were missing for ourselves, like in the middle, the RAV2 SAP, courtesy of AEC networks, for the 2015 Plugfest, which was really needed by that time, and uncovered intrinsic problems in a standard that we want as many people as possible to adopt, is that there are degrees of freedom, and sometimes those degrees of freedom are complications that need some tools to be solved. We also needed to learn a lot about PTP, so thanks to Meinberg for the PTP track count, and merging proposed Hahnemann, which allowed to envision an AES67 that would work almost like Dante.
Yeah, and these tools, of course, again, were required to develop the stuff, but also to be able to use it. And what is a bit covered here, but it's running under the hood with the PTP track count, is Wireshark, which is a very important tool, which you almost cannot miss if you're working with audio over IP. This is something like a Swiss knife, or it's a big Swiss knife, but
Yeah, and
you
yet
need it.
we need it, but we should not need it. I mean, this whole idea of tools is that what I tell to my students when I teach audio over IP is that when you use Wireshark, if you have to use Wireshark, send me an insult email and explain to me what was the problem, because it's my fault, his fault, his fault that some tools are missing, and we need to provide those tools to the user. We cannot expect the sound technician to learn Wireshark and to see through the matrix of, Wireshark packets.
Yeah. Well, over the time, of course, once you have the standard specified and you have a few manufacturers implemented it, it's required to get momentum and to create momentum on the market and deploy it on a broader scale. So at some point, some bigger players got on board, and one step was, for instance, that Yamaha decided to participate in the Plugfest, which was a big step because Yamaha is just a huge company, and if they decide to adopt a particular format and use it in their products, that would be what was supposed to be a big step. And yeah, well, there were some others that joined, and yeah, another thing was that VSF and JTNM came up with the Dirty Hands event, the beginning of specifying ST2110, and then the decision was made that the audio part of ST2110 was actually referring to AES67, so not even just doing something similar or like reinventing the wheel in a different shape. It's actually more or less a plain reference to AES67 with a very few adjustments, but nothing really harmful. So this was, I think this gave another boost to the whole thing.
We have to admit, the audio guys are cool, but the video guys, they have way more money. So
Yes. And the other opportunities to boost this is actually to think about OEMing the stuff. So once you have the technology designed, did implementations, and went through the process iterations of optimizing everything, creating an ecosystem that works, and making sure that the interoperability is actually there, then you can also start deploying the technology as an OEM, and then this makes it easier for other, probably small companies or big companies that are too busy doing other stuff to be able to allocate resources to develop a new technology, to incorporate what is already there and make sure that they are interoperable as well. And by that, it's also possible to spread the standard into the market. And I think this is still in the works. There's space to improve, but there are a couple of OEM modules available, and yeah, some bigger players actually use them instead of doing their own stuff. And yeah, the result's quite impressive, right? You looked up the numbers.
yeah. So we asked for we asked Roland Hemming to give us some numbers, and right now they are more than 94% of audio over IP devices on the market that claim somehow AES67 compatibility. Whereas in 2014, like 6 months after the release of the standard, there was only 3 of them that were claiming AES67 compatibility. So when you see that AES67 is the de facto standard with interoperability.
Yeah. So the question is, what comes next? What will be the next steps, and what needs to be done, or what can be done? And yeah, one thing is that there's still, particularly in the user base, some hesitation or fears, some myth about using network, and I think this is something we need to work on. This counts in to the education side of it, that we really have to make sure that everybody feels safe in using networking, feels comfortable in using network-based things, and that this is not something a bit blurry or probably shaky or unknown, but to be confident that you can handle this and that the technology that runs on top of it is working well and is stable. And yeah, as I said, we need to educate the customers. And then there's, of course, the demand for deterministic transport. And this is something that is addressed by different initiatives. And another quite famous one is the TSN AVB thing that uses standards to define the transmission bandwidth and make sure that there's a reservation for bandwidth and that important traffic like audio packets are not pushed away by other events on the network. And I think these are things we can still improve or make more obvious that it's actually there and it's actually working. You have this example of Ethernet not being designed for real-time transmission with the stock exchange thing. You said yesterday, I think, so that you said that it's funny that people say Ethernet was never defined to be. You remember it?
Yeah.
Go for it.
Sorry. Yes, indeed. Yeah. So in the 70s, my pre-story, because I was born in the 80s, but so Ethernet was never designed for real-time transport. You know when you send a packet, but not when you receive that. And I used to tell that every time I do a training on AES67. And why the effing do I do that? Because I paved the way of telling people you do not trust the Ethernet. And so there's this difference between knowing what to say and saying it at the right time. And it goes along with deterministic transport. People are scared of what they don't know, what they don't see. You don't see the audio over the internet. You cannot take a magnifying glass on your Cat5 and see the number of streams that are passing by. So this demand for deterministic transport is also a seatbelt again, or a helmet that you put on your system so that when it crashes, it doesn't crash too bad or it doesn't crash at all. And the last one is the more important, because we are not the only one going to the network, and AES67 was a big step of a whole industry of live event and media content production moving into real-time networking. And so we also have to deal with other protocols on the network. And be it video, be it lightning, be it any way or any sort of control, those protocols also need to be converged on the same network or at least the same infrastructure. And therefore, there's the evolution here of the whole industry that needs to take into account not only the needs of one part, but the need of a whole system.
Yeah, and I mean, to wrap it up, baseline is that the implementations for AES67 are there and they are proven and working. We made many test events, and there's the JTNM tested batch that was performed several times to make sure that the interoperability and also the implementations are really solid and working well together. And yeah, it's actually there. It's working, and it's something you can use today. So yeah.